So what I'm going to do in this video is go through how to find Tn for a quadratic pattern. So the first thing that we need to look at is, well, what is Tn? And Tn, I've given an example here of an equation of Tn. So Tn here is n squared minus 2. So what this equation tells us is any term in a sequence, in a quadratic sequence. And how you find those terms is you take out n and you put in the term that you were looking for. So if I want the first term, I will take out n and I'll replace it with 1. So over here, you can see that t1, which is the first term, is 1 squared minus 2. Okay, so instead of being n squared minus 2, it's now 1 squared minus 2, and I get my first term as minus 1. Second term, 2 squared minus 2, and I get 2 as my second term. The third term, t3, 3 squared minus 2. Fourth term, 4 squared minus 2, and so on. And what that gives you is it gives you a list of numbers. T1 over here, T2 is 2, T3 is 7, T4 is 14, and I could keep going. What we're being asked at Leaving Cert is to reverse that. So they will give you the list of numbers and they will ask you to find out what Tn is. So I want to show you a shortcut that sometimes works, doesn't always, to find Tn. So the first thing when you are given your list of numbers is to write them down beside what term that they are. So I'll do a little table here of where I will write down n and I will write down the number. Okay? So when n is equal to 1, what is my first term? So n is equal to 1 means that it's the first term. And my first term here I can see is minus 1. When n is equal to 2, my second term is 2. When n is equal to 3, which is the third term, the value of that is 7. When n is equal to 4, the value of that is 14, which is the fourth term. And really what we're trying to do is we are trying to find a relationship between this number n and the actual term here. So the first thing you're going to do is you are going to find out what the second difference is. So every quadratic, you are going to have a common second difference. So what is the difference between minus 1 and 2? Well, that's 3. What is the difference between 2 and 7? Well, that's 5. What is the difference between 7 and 14? Well, that's 7. So you can see your first difference changes, but what is it changing by each time? And I'm going to overlap here on my table slightly. You can see that it is going up by 2 each time. So that here tells us that when I'm writing out Tn, I have that number, so my second difference is 2, half of 2 is 1, so Tn is going to look like 1 n squared plus some other part, okay? So my coefficient, or the number beside the n squared, is going to be 1. Now, what is n squared? So you do another little part of your table here and you look at n squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And then you start to look at, okay, well, what do I have to do to n squared to end up with my term? So when n is equal to 1, n squared is also 1. And what do I have to do to get from 1 to minus 1? I have to subtract 2. I'll do this in green here. So I subtract 2 to get to that, to get to the actual first term. N squared, when n is equal to 2, well, n squared is 4. And what do I have to do to get from 4 to 2? Again, I have to subtract 2. When n is equal to 3, n squared is 9. And to get from 9 to my third term, again, I have to subtract 2. So that's the pattern. That's what you're finding. When you have a nice simple pattern like that, you basically know what Tn is. So Tn is n squared take away 2. And that's it. Tn in this case is n squared minus 2, which we know is right because that's what we started with up here. So that allows you to find Tn without doing simultaneous equations. So let's look at another example. Just to clarify, by the way, it is Tn is equal to n squared with the 2 on top, not on the bottom as a subscript, which I had previously. Let's look at one other example very similar to that before we move on. And let's take the following list of numbers. So let's say you were given the numbers 3, 6, 11, and 18. Okay, you were asked to find Tn for that list of numbers. So the first thing that you are going to do is you are going to find what the common second difference is, which is just called the second difference. So we're looking at a difference of 3 here, we are looking at a difference of 5 here, and we are looking at a difference of 7 here. So our second difference is going to be 2. Now, because our second difference is going to be 2, when we write down the general equation for Tn, so it's some number a times n squared plus some number of n's plus another number on its own. We know that this a here is half of our second difference. So already we know that Tn for this sequence of numbers here, and we know it's an arithmetic sequence because the second difference is constant. We know that the Tn for this sequence of numbers is going to look like Tn is equal to n squared, and we don't know what's after that. So like we did before, we'll put down our values for n squared here, and we will put our terms over here. So when n is equal to 1, n squared, let me just be very clear on what we're doing here. So when n is equal to 1, 2, 3, 4, we have n squared is equal to 1, n squared is equal to 4, n squared is equal to 9, and 16. Now, what are our actual numbers of the sequence that we are given? The actual numbers, the first term is 3, the second term is 6, third term is 11, and the fourth term we're given is 18. So if we know that Tn is given by n squared, well, n squared will get you to this point here, okay? So what do I then have to do to this number to get to the actual first term? And you can see here that what I have to do with that is I have to add 2 onto it. So the second term, when I get n squared, what again do I have to do with n squared to get it to the actual term? Well, again, I have to add 2. And you'll find for all of these here that adding 2 to n squared will give you the arithmetic sequence that's up here. So that means that Tn for this arithmetic sequence here is equal to n squared plus 2. Now that's one last example then, and we look at something a bit more complicated. So the next sequence of numbers that we're going to look at is the following. So 8, 14, 24, and 38. Now again, I'm just giving you the first 4 terms of this sequence, and what we have to try and do is find Tn. So first thing, you can get your common difference. So between 8 and 14, we have 6 here for this. Between 14 and 24, we have a difference of 10. Between 24 and 38, we have a difference of 14. So your common, there isn't a common first difference. Then look at the second difference. The second difference, the difference there is 4, and the difference here is 4. So our common difference, D, second difference I should say, is 4, which means that your Tn for this is going to look like 2n squared plus or minus blah blah blah. Okay, so you take your second difference, you divide it by 2, and that gives you the coefficient of n squared, or the number beside n squared. So now let's take our table, and we have n here, and then we are going to put 2n squared here. So the previous tables we put n squared, and the reason we put n squared was that the coefficient of Tn was always 1, but because we have the coefficient of Tn here is 2, so then we will put our different values of n. So again, for the first term, the second term, the third term, the fourth term, and we'll write down what the first term, second term, and third term actually are. So the first term here is 8, the second is 14, the third one is 24, and the fourth one is 38. So we know that the start of Tn is 2n squared. And then are you adding something, are you subtracting something to end up with the term? That's what we're going to see. So n is 1, 2n squared is 2. What are we doing? What do we have to do to 2 to get to 8? And what you're doing there is you're adding on 6. Now, when n is equal to 2, 2 times 4 is 8. And what do I have to do to 8 to get up to 14? Again, I'm going to have to add on 6. So you can see already that once you have a pattern of even 2 of them, it's going to continue the whole way along. So we'll just do the n equal to 3 for completion here. So 3 squared is 9, 9 multiplied by 2 is 18. And what do I have to add to 18 to get to 24? Correct, 6. So now we know that Tn is 2n squared plus 6. And that's it.